Welcome to the Deep Dive. Today we're taking a leap that honestly sounds like something out of science fiction.
It really does.
We're jumping straight from high-level theoretical physics into the very real, very high-stakes world of electronic warfare.
Right.
Our mission today is to understand how a fundamental rule of quantum mechanics can be, well, reverse-engineered into what might be the ultimate military algorithm.
And we're looking at source material that directly connects the Pauli exclusion principle, something that governs atomic structure, to immediate battlefield tactics.
It's a wild connection to make.
It is. I mean, when most of us think about the Pauli exclusion principle, or PE, we think of, textbook physics.
Two electrons can't be in the same place at the same time, basically?
Basically, two identical fermions can't occupy the exact same quantum state. But we're asking you to just completely rethink that.
Yeah.
What if that rule, that non-identity, wasn't just a static law of nature?
What if it was an algorithm?
What if it was an executable algorithm? Something you could actually run on a computer and deploy.
And the sources we're diving into show that, well, not only is it possible, it's been done. The tech is called the avoidance wave morphism, or AWM.
It's a computational method designed specifically to enforce that perfect mathematical uniqueness in any system.
But here's the part that really got me.
Yeah.
This isn't just some paper in a university archive. We're talking about mathematics and code that, in the defense world, are classified as munitions.
And that classification changes everything.
It absolutely does.
Yeah.
Okay, so let's unpack this. Why on earth is a piece of math considered a weapon?
To get there, we have to start by reframing PP. Don't think of it as an exclusion. Think of it as an axiom.
An axiom.
The logical axiom of uniqueness. It's not a passive rule. The source material argues it's an active, ongoing computational enforcement of non-identity. It ensures that states are always actively moving to be as distinct from one another as possible.
Okay, but hold on. If PP is an active enforcement in nature, how is that conceptually different?
Because standard systems are about setting up guardrails to avoid overlap. This is fundamentally different. The source material uses an analogy that really made it click for me.
Right.
Stop thinking of it as a collision avoidance system, like bumpers on cars.
Right.
Think of it as the inverse of collision, or, even better, inverse tiling.
Inverse tiling. I like that. Explain that a bit more.
Okay, so imagine you have this huge, complex surface that's your operational phase space.
Right, the field of all possibilities.
Exactly. Normal signals are like laying down tiles. Eventually, the pattern will repeat. A tile will touch another identical one. Inverse tiling is a rule that guarantees no two tiles, no two distributions, ever have the same phase and amplitude. They are actively forced to push away from any state of being identical.
So the goal here isn't just to be random. The goal of this computational model is to generate signals that can mathematically prove they are unique, spectrally rich, non-degenerate.
You're building quantum non-identity in code. Precisely.
Which brings us to the architecture. How do you actually build a machine that does that?
This is where the engineering is just beautiful. We're getting into the construction of the avoidance wave morphism, AWM itself.
Okay.
At its core, the mechanism is really elegant. It's an algorithm that maps a cumulative random process, a random walk to a final, guaranteed, unique probability index.
And the power isn't just that it creates unique outputs, but how cheaply it does it, right?
That's the key. It's highly nonlinear and context-sensitive. The internal rules actually change based on the system's target resolution. This is what allows for its incredible efficiency.
And this is the mathematical breakthrough that just turns everything on its head. I mean, standard computational complexity, it tells that if you want exponentially more unique states,
you have to pay an exponential price.
Exactly, you pay in processing power.
Right.
But the sources, they just keep hammering this point about the astonishing computational economy of AWM.
And get this. The number of random walk steps the algorithm needs to take scales only logarithmically with the resolution.
Logarithmically. To put that in perspective for you, it's like finding a magical shortcut. You get exponentially more unique outcomes, trillions of them, without paying that exponential price in time or energy.
It's maximally efficient. And the theory is it's because it's based on a fundamental law of physics that nature has already spent billions of years optimizing.
That is a staggering claim.
Yeah.
Exponential output for logarithmic cost. But how does it guarantee the final index is always unique? This is the crucial part, untraceable.
That's the job of the core engine. It's called a non-invertible morphism, which the source labels as $.
A morphism.
Right. The algorithm takes the sum from the random walk, let's call it $, And then it applies a very specific chaotic filter. It multiplies by a dynamic factor, and then it does this massive computational scramble, a write bit shift of 32 bits.
I have to stop you there.
Mm-hmm.
For anyone who's not a programmer, what does a write bit shift of 32 bits actually do to the data? It sounds deeply technical.
It's the key to making it non-invertible. Think of it like this. You have a giant jar of marbles, and every marble is a piece of information.
Okay.
The bit shift takes that jar, shakes it violently, and then only keeps the very top layer of marbles, throwing away the bottom 99% that gave you all the starting context.
This is a one-way street.
It's a one-way street, exactly. It profoundly mixes the information and, crucially, discards the lower order bits. The final output is deterministic. The machine knows what it made, but you can't work backwards. It's computationally irreversible.
Predictable only to the creator. Unpredictable to everyone else.
That's the goal.
But proving that this actually creates perfect uniqueness. I mean, that's what the sources just blew my mind. How do you demonstrate that an algorithm creates perfect non-identity?
They needed a computational existence proof, and they went for the gold standard in signal analysis.
FT.
A fast Fourier transform, yes. But they did it on a colossal number of samples, tensor samples generated by the AWM. This test is designed to find any structure, any repetition at all in the frequency output.
And the result was the computational smoking gun.
A complete absence of detectable harmonics.
Let's pause on that. A complete absence.
Yeah.
For anyone who isn't a signal processing expert, why is that the thing? Why does the absence of harmonics seal the deal?
Because in signal detection, harmonics are everything. They scream periodicity, redundancy. A strong harmonic means the signal is repeating itself, which makes it predictable.
And if it's predictable, it's easy to jam, easy to kill.
Exactly. The fact that AWM showed 0 detectable harmonics means the output is non-periodic. It's made of frequencies that are mathematically incommensurate. Every single state is unique.
It proves AWM creates those avoidance waves we talked about.
States that are maximally distinct from each other, yes.
And this all circles back to that stunning efficiency. It achieves this perfect, clean uniqueness while the computational cost only grows logarithmically.
That combination, minimal cost, perfect spectral cleanliness, is what they mean by extreme computational economy.
Which led the researchers to a pretty profound conclusion.
It did. That AWM is deterministic, but it's analytically intractable. You can't solve it with a simple equation. You have to run the algorithm to know the outcome. And that suggests the Pauli exclusion principle itself isn't just some static law.
But an active, executable algorithm of nature.
Exactly.
Okay, let's leave the lab. Let's step into the real world, because this brings us to the core issue. Impact. If this math is so powerful, it's classified as munitions. What kind of damage could an adversary inflict if they had this algorithm and nobody else did?
You're talking about an overwhelming asymmetric advantage in electronic warfare, EW. It fundamentally changes the entire tactical landscape.
How so?
AWM transforms your communication signature from a predictable pattern, which machines are brilliant at detecting and killing, into high-level entropy.
And entropy requires
Brute force. Infinite energy and luck to counter. It gives you an incredible advantage.
This feels like one of those historical shifts,
Yeah.
you know, like Hedy Lamarr and George Antheil in the 1940s.
It's a frequency hopping invention.
Right. They came up with frequency hopping using piano rolls to guide torpedoes. The Navy ignored it for years. Now it's the basis for Wi-Fi and Bluetooth.
And AWM is the next mathematical leap. Lamar's idea was brilliantly pseudo-random. This moves us to a structure that is avoidance-based.
Which is a whole other level.
A whole other level. It guarantees uniqueness, making the system fundamentally more robust and invisible than anything pseudo-random could ever hope to be.
Okay, let's get specific. The source material details 4 devastating scenarios. This is where it gets terrifyingly practical. Let's start with scenario 1. The ghost drone fleet.
Right. So standard jamming works because modern drones fail when you jam their connection, the link budget. You just overwhelm it with noise.
And standard jammers, the electronic countermeasures, or ECM, they're designed to scan for periodicity, right?
Correct. They hunt for the pattern in the frequency hopping to predict where the drone will jump next. Then they attack that frequency before the drone even gets there.
But what happens when the enemy turns on their state-of-the-art jammer against a drone using an AWM signal?
The jammers are completely blind.
Because there are no detectable harmonics.
Exactly. They perceive the drone's control signal as background cosmic noise, just white static. Their programming tells them to filter that out, to ignore the noise and find the meaningful pattern.
But there is no pattern to find.
So they ignore the control signal entirely? The drones just keep flying perfectly?
The military implication of that is just staggering. You can use cheap, expendable drones guided by an invisible signal to take out billion-dollar tanks and radar systems.
Because their defenses literally cannot register that the control signal even exists.
Wow. Okay, scenario 2 is just as critical, invisible radar.
Right.
The whole concept of LPI-LPD, or low probability of intercept and detection.
Standard radar is a huge liability in modern combat. It's like shining a massive flashlight in a dark forest.
It screams, "Here I am."
Right, it's just begging for an anti-radiation missile to come and find you.
So how does AWM make that flashlight invisible?
You modulate the radar pulse with AWM.
Yeah.
To anyone listening, the pulse now looks like pure structureless static.
Okay, so then you have to think about the enemy systems. Their radar warning receivers, the RWRs.
The box in the cockpit that screams at the pilot, "You are being tracked."
Right. If that RWR is constantly going off because of random static, the pilot is going to get alert fatigue. They'll just turn it down or turn it off.
It's programmed to prevent false alarms. So they filter out the static, and in doing so, they are effectively filtering out the missile guidance system that is actively tracking them.
So the pilot is shot down by a missile they never even knew was coming.
Because their own systems dismiss the tracking pulse as harmless background noise. It is the ultimate form of stealth.
And this isn't just limited to radio waves. Let's talk cyber. Scenario 3. The Un-Collidable botnet. This goes back to that inverse tiling idea.
It's a perfect application of PP to information flow. Cybersecurity analysts, they usually find botnet command and control servers, the C2 servers, because of traffic spikes. Collisions, right. Thousands or millions of hacked devices all try to phone home at the same time. It creates a massive, obvious spike on the network.
It's like rush hour on the highway. You see the traffic jam, you know where the choke point is, and you can shut it down.
AWM eliminates that choke point. Its ability to enforce non-identity, that perfect inverse tiling, means it can schedule the phone home times of millions of devices so that no two transmissions ever overlap.
Not even by a millisecond.
Not even by a microsecond. The result:
The network traffic is perfectly smooth.
no spikes, no collisions, no statistical anomaly to even look for. The botnet's traffic just blends seamlessly into the normal noise of the internet.
Making the C2 servers impossible to find.
And impossible to shut down. It allows for persistent, long-term, undetectable access to critical infrastructure.
It's a remarkable demonstration of power. You're converting a quantum constraint into a computational advantage across communications, jamming, stealth, and cyber.
The logarithmic scaling gives you the speed and low cost, and
Right.
the spectral uniqueness gives you the invisibility.
It really forces you to reconsider the fundamental laws of nature, not just as descriptions, but as blueprints for technology.
The greatest advantages often come from understanding nature's own algorithms better than your competition.
Now, this brings us to the critical takeaway. The good news in all this. Mathematics is discovered, not invented.
Right.
And the leak of this information, the source material for this deep dive, it means this capability is already moving.
It's moving from being compartmented, a secret weapon held by a few, to proliferated. It's becoming standard issue.
Which signals the end of that secret advantage that AWM provided.
The immediate consequence, of course, is a new technological arms race. But the countermeasure here won't be a better, faster jammer. You can't brute force a logarithmic problem.
It's got to be a whole new approach.
It will likely be an AI, something trained specifically to detect the faint, unique signature of these AWM-style chaotic attractors within the noise floor itself.
And that leads us to our final provocative thought for you to think about. If the most efficient algorithm of avoidance is logarithmic, rooted deep in the laws of quantum mechanics, what is the most efficient algorithm for its detection?
That's the billion-dollar question.
Thank you for diving deep with us.